Alrighty, this is G3 Consulting. We are now looking to plan salaries for a baseball team. We've got to acquire some players in order to try to form up the best team. So we have divided a group of potential players into two different types. We have the star players and we have the role players. Of course, the star players are going to get all the headlines. They're going to be the ones everyone wants to watch, but they're going to be quite a bit more expensive, whereas the role players are going to kind of end up being the base of your team. In this case, we're actually going to try to minimize the amount of money that we're paying them. So that is the objective function. We'll say that this is in millions of dollars. So per star player, it's going to cost us $2 million. And per role player, it's going to cost us $1 million. We're wanting to pay as little as possible, but it's very important that we get minimum amounts of certain things that are really important to us. So down here, we've got our constraints. We've got home runs, we've got defense, we've got base running, we have celebrity status, and we have leadership. These are all things that are very important to us, so we have set minimum amounts that we have to achieve. We need, and these values here are our utility values. So for home runs, for instance, your star player has a utility value of 50. Role player is not going to hit many home runs. He only has a utility value of 10 per player. Each star player is going to provide you a value of 20 defense. Each role player is going to be a little better on defense. He'll provide you a value of 35. Each base runner is going to provide a value of 15. Or each star player will provide a base running value of 15. Role player will provide a value of 25. We need a minimum of 250 of that. Celebrity status, obviously the star player will provide 40 utility of celebrity status. It's kind of important. You got to get fans. Fans won't come to the game unless they know there's some star players, so we got to have some big names on our roster. Whereas the role player, they're not going to provide as much celebrity status. We need a minimum of 300 of that because we got to fill the seats with people. They'll buy the jerseys of the star player. And finally, we've got leadership. Star players may not provide as much leadership, whereas we expect that a lot of the role players will provide a lot of leadership. Overall, we need a utility value of 400. In all, we will have our objective function is the number of players of star and role times the salary per player that we'll be paying them. So $2 million per star player. $1 million per role player, and so that's how we set it up. You can see here in the way we set up our solver. Of course, obviously it has to be an integer. You can't get half a player. I don't think that's how it works. And then we set our objective functions that are these are greater than. These aren't capacities. This is a minimum amount we have to have on our roster if we want to have a very good team. We'll also make unconstrained values non-negative. And then to go ahead and look at, all right, now Jeff is here to take a look as we graph these equations.
So in order to begin solving this problem graphically, we must solve for one variable in each equation, then set the equations equal to each other in order to determine the extreme points. So we chose to solve for r in each equation. Then once you have the equation for r for each constraint equation, you simply plug that into your table and then multiply that by your variable, the column on the left. Once you have that information in place, you create a graph and it will plot your lines out. Then once you have your lines graphed, you can solve for the extreme points numerically. So you set the equations equal to each other, solving for one variable. We've already solved for r, so we'll be solving for s. Once you have the value of s, you simply plug that value into either equation and solve for r. At that point, you will have solved for your extreme point.
And there is, just looking at this graphically, of course, it's kind of difficult because the feasible area continues up and out. We know that our solution is going to be along the intersections of two lines, so we've circled it right here. It looks, just from our looking at it, it looks like visually, it's the intersection of equation 1 and equation 5 is this extreme point that's circled here.
Yep, so if you set these equations equal to each other, then you'll be able to find our optimal solution. So for the number of star players, we took equation 1, set it to equal to equation 5, and we got 8. And so when we plug that into equation 1, where you plug S equals 8, then we get R as being 7. So that gives us with 8 star players and 11 role players as our optimal solution.
And then we plugged that back into the objective function, and we found that the value for the salary that we're going to have to pay is 27. So $27 million. 8 and 11 were the intersecting points. So we're going to need, for this team, we will need 8 star players. We will need 11 role players. We ran into some challenges that we found, particularly the minimization part is pretty easy to grasp. But the visualizing on this graph with, instead of capacities, which is what you normally see with linear programming, instead we did minimums. We needed a minimum value of our home runs. We needed a minimum value for our defense, a minimum value for our base running, a minimum value for our celebrity status, and a minimum value for our leadership. We set the minimums equal, a little bit different to each other. But the fact that we needed those minimums made for some interesting graphing here. As you can see, there's only one extreme point that, we could look up here, but because these are non-negative, but there's only one extreme point that borders it. Some of these others, like equation 4, never comes close to the feasible area. Any suggestions that anyone has for how we can optimize this a little bit more? We do think that this is very practical. It's extremely useful because you can see how much of each you need, how much you can kind of splurge a little bit with your star players, whereas the role players are going to be a little bit less expensive, but you're going to have to build your team with mostly role players because you can't afford that many star players. They don't provide enough value of things like base running and leadership. So those utility values are set to be a little bit lower, particularly the leadership one. And so that makes it a little bit, that ensures that you need a mixture of both. But if anyone has anything else to add that can help us improve this model, we'd appreciate it.